So I'm going to go over worksheet 3, but then if we have time, we can pick out a problem from worksheet 4. Worksheet 4 doesn't have everything, but I think it just has some types of problems that I feel students probably practice with. So, so if you picked up worksheet 4, you can also work ahead or try those problems on your own during this time, and then you can check your answers with the key. Okay, so number 1. This is page 41. So number 1, we're just finding the sum. So we can do this by hand. There's only a few terms, so we're not going to use summation formulas here. So we can just plug in 1. Ours our lower bound. So our smallest I value to plug in. So plug 1 in for all the i's. And then the summation means we're going to add plus next term I equals 2. And then next term I equals 3. We stop at 3 since this is the last value that we plug in for I. And the rest is your calculator plugging it. Number 2, use sigma notation to write the sum. Now, when you write the sum, there's potentially more than one way to write it. Okay, so but we could create a formula starting at I equals 1, but it just feels like it's more convenient to start at 3, since 3 and 27, 4 and 64, 5 and 125, 6 and 216 have a nice connection between these numbers. So I'm going to start this one at I equals 3. And then I equals 4 should produce this next term, I equals 5, and then I equals 6. So then here's my summation. Starting at 3, ending at 6. If you look at each of these terms here, every term has a 7 in the square root in the numerator and denominator. So we know that those pieces will stay. And then the 3, 4, 5, 6, this has to be something involving I because these are the numbers that are changing. And it'll just, we're not going to make any changes to the term that we plug into the rule. Denominator, though, this is I cubed. I cubed will get from 3 to 27, 4 to 64, 5 to 125, 6 to 216. Some common rules involve, maybe you're adding a value, maybe you're raising it to a power, maybe you're multiplying by a number, maybe you're raising a base to that exponent. Something along those lines of these patterns. Number 3. Use four middle rectangles to approximate the area of the region bounded by our function. So the only rule that we need here is width formula, which is b minus a over n. A value is 1, b value is 7, and n is 4. So 3/2 is our width. We're going to start at the left endpoint and move our way to our right endpoint. 1 plus 3/2 is 5/2. Plus 3/2 is 8/2. Plus 3/2. And plus 3/2. 14 over 2, which is 7. We're not quite done yet. We need to use midpoint or middle rectangles. So I need to find the midpoint, each of these subintervals. So the way we find midpoint is think about how you find average of two numbers. You're going to add and divide by 2, right? So 1 plus 5/2 is 7/2 divided by 2 is 7/4. This is 13/4. Okay, any questions about finding those midpoints? You can use your calculator if you like. Add up two numbers, divide by 2. So area, we're just doing width times height for each of these. Make sure that you're doing f of these midpoints, right? We still have to plug these numbers into the function here. So 3/2 times f of 7/4, 3/2 times f of 13/4, 3/2 times f of 19/4, and 3/2 times f of 25/4. And after you have that in function notation, you can just take each of these fractions, insert into the x of your function to get your y values, and then you're off to multiplying and adding your 4 area rectangles. Any questions with 3? Okay, so number 4, use 3 middle rectangles to estimate the area between the curve and the x-axis from 1 to 15. So we have to break up the intervals from 1 to 15 into 4 subintervals. So let's see, what if we go from 1 to 6, and then 6 to, I'm sorry, 3 rectangles. 3 intervals, 1 to 6, 6 to 11, and then 11 to 15. You're just looking at where the brackets are hitting the order pairs. So 6 minus 1 will give you the width of your first rectangle. 11 minus 6 will give you the width of the second rectangle. 15 minus 11 will give you the width of the third rectangle. And we want 3 middle rectangles, so we want to pick out the y value in the middle of each of the subintervals. So 2 would be the height of your first rectangle. 3 would be the height of your second rectangle, and 6 would be the height of your third rectangle. And then we just add up those areas. So 5 times 2, 5 times 3, and 4 times 6. Right, part B, 3 right-handed rectangles, but now we're only spanning from 5 to 11. So we'll try this, 5 to 6, 6 to 8, and 8 to 11. Okay, subtract the x values to get your width. 6 minus 5 is 1, 8 minus 6 is 2, 11 minus 8 is 3. And then from each subinterval, you want to choose the right y value. So 1 times 7, 2 times 3, and 3 times 1. Next up, use 4 trapezoids from 6 to 15. So we can do 6 to 8, 8 to 11, 11 to 13, and 13 to 15. The area formula is 1/2 width, height 1 plus height 2. Careful though, if the trapezoid spans across more than 2 order pairs, make sure that you're only choosing the 2 heights at the end. Don't choose more than 2 heights for each trapezoid. So 1/2 times 2 times 7 plus 3, 1/2 thirds times 3 plus 1, 1/2 times 2, and then parentheses 1 plus 6, 1/2 times 2, parentheses 6 plus 5. I hope you guys find these easy as well. I think the issue that students have with this is, just little things like either adding instead of subtracting, pulling from the wrong row or from the wrong for the width and height. So as long as you're clear on that, it should feel like a quick, easy process to find these areas. All right, number 5. Now we're using the area definition, which I will give you on your formula sheet. We want to start off by finding the width. So width is b minus a over n. Oh, and then again, as a reminder, when you're dealing with these problems here, don't use width equals b minus a over n. You're gonna get some wrong values if you use this width formula for table of values. Okay, table of values, you're supposed to find the width on your own separately. You're not going to get one single width out of your like number 3. So our width is 2 over n, b minus a over n. We want to hold on to our n value because we want to eventually push that n out to infinity. So first step is to insert that width into your area definition, which is width times f of a plus width times I. And my a value is -1. Next up, we have to get that function notation into an expression that we can use. So we're going to take this quote unquote x value and put it into the x of the function. So you're going to rewrite this expression and turn it into 3 minus 2x squared, but then the x will get replaced with this whole expression. Okay, take the time to FOIL out or expand out your parentheses there. So basically that's -1 plus 2 over ni times -1 plus 2 over ni. If I were to expand that out, this is what I would get. 1 minus 2 over ni minus 2 over ni, which gives us -4 over ni, and then plus 4 over n squared I squared. I'm going to distribute a -2 through the parentheses. So -2 times negative times 1 is -2. -2 times -4 over ni is positive 8 over ni. -2 times 4 over n squared I squared is -8 over n squared I squared. Combine some like terms. The 3 and 2 combines to be 1. Now I'm ready to multiply the width into my cleaned up height portion. Multiply the 2 over n through, And now I can begin exploring my summation rules. And make those substitutions in terms of n. Okay, replace summation 1 with n, replace summation I with n times n plus 1 over 2. I squared is n times n plus 1, 2n plus 1 over 6. Within each fraction, you're just trying to find the term with the highest degree. This one, 16n squared, is the highest term over 2n squared. And here, 16 times n times n times 2n is negative 32n cubed. And then just pull the fractions here, 2 over 1, 16 over 2, 32 over 6, and then add those terms together at your area.
When we distribute the two through the equation,
Right here,
yeah.
it's negative 2.
Oh, so like we multiply everything by negative 2 so the signs change,
Yeah. Mhm.
and then you add, then you, oh yeah, no, you still subtract that. All the signs change.
Right. Okay, any questions for the page? Okay, next page, number 6. We're just, all these problems are basically all power rule. I didn't put a trig problem on here, but I think I put a trig problem on the worksheet 4, so we can get extra practice there. But really everything here on this back page are just variations of power rule. So it says find the integral of g of x dx. So we start off with our notation, set up our notation here. We know that if we want to do power rule, all of our parentheses have to be resolved. So I'm going to FOIL out that 2x minus 1 squared. Once I take care of that, then I can distribute the x through. And then once I get all the parentheses taken care of, then I should have nice individual terms for me to apply power rule. So I'm going to take care of the 2x minus 1 and 2x minus 1 first. I get 4x squared minus 4x plus 1. Take the x, distribute that through. And from there, we just apply power rule and clean up. Number 7 is also power rule, but we do want to take some time to rewrite some of our terms so we can get some of them ready for power rule. Some of them are already ready to go, but a lot of them are not. So the 4 over cube root of x, we have to get that to be a rational exponent and make the x come up to the top. Root x, just x to the 1/2. 3x squared is okay, that's fine. And then the 1/3 x to the 4th. Make sure that when you bring the x up, the 3 stays below, right? We don't want to bring this as 3x to the negative 4. It's 1/3 x to the negative 4. So every term is now ready for power rule. I'm still holding on to my integral notation because I haven't done power rule yet. But as soon as I apply power rule, I can drop these and add a plus c at the end. Okay, so add 1 to negative 1/3. I get 2/3 over 2/3. 3/2 over 3/2. 3 over 3. Negative 3 over negative 3. And then clean up after that. Number 8, we're going to split up into individual fractions. I didn't work it out that way on my key, but let me work it out that way here. Any question with 7, though? I think merge the fractions by subtracting exponents. 3 minus 1/2. Here, these are the same terms. These just cancel out. The only thing I have left is just a 2. And here, 1/4 minus 1/2 is same thing as 1/4 minus 2/4, which is negative 1/4. Every term is ready for power rule. I can apply a power rule to each term now. Constant goes to a degree 1. Sorry, 1/4 minus 1/2 is negative 1/4, my bad. So negative 1/4 plus 1, the same thing as negative 1/4 plus 4 over 4, which is 3/4. And clean up by moving these denominator fractions up. Okay, number 9. It says find a general expression. So we're going to take the antiderivative twice, since we're all the way down at the second derivative level. Each time we do, we're going to have a plus constant that shows up. So we're not going to be able to find those values since they're not going to give that to us. And so that's why it's called a general expression. But we first set up our integral to indicate what we want to do. So after we apply this calculus process, the result is going to give us f prime. So power rule. As soon as we apply power rule, we can drop these notations, but the result is still equal to f prime. Okay. Add 1 to the exponent. -1 becomes minus x plus c. So this takes us to the halfway point of our problem. Next step, if I want to find our function, I'm just going to take the integral of my f prime. So power rule again. X to the 4th becomes x to the 5th over 5. X cubed becomes x to the 4th over 4. 1/2 x squared becomes 1/2 times x cubed over 3. X becomes x squared over 2. C becomes cx, and then it's going to produce its own constant as well, plus k, or you can say c sub 2. And just clean that up. Basically, you're just applying power rule twice. Yeah, so if my denominator is a fraction, then I have to flip it. But if my fraction is just a number, I can just pull it out as that fractional value. Yeah, so with that 3 there, I'm just thinking of it as, oh, that's just times 1/3. But if it was 1/3 down here, I got to flip it up to the top and make it 3. Number 10, same process as number 9. It's just that each time we find the antiderivative, we're going to have an order pair to help us solve for that constant at that level. And we'll update the equation and take the antiderivative again. Another plus c shows up, and then we can plug in that order pair at that level as well. So to find f prime, we're going to take the antiderivative of our f double prime expression. X cubed over 3 plus 18x squared over 2 minus 4x plus c. At this level, well, I'm going to clean this up, and then I'm also going to plug in my order pair at that level. So 9 plugs in for f prime, -1 plugs in for x, and I'm just trying to isolate and solve for c. In this case, the c value goes away to 0, so my f prime won't have a constant. It will just be a plus 0 here, which I can just leave out. So I can take the antiderivative of my f prime to make it rise up to the f of x level. We go through power rule, plus k or plus c sub 2. Take the order pair, 3 in for y, 1 in for x, and solve for k or solve for c sub 2, and then update your function again.
Good morning, teachers. Please take a moment to check your email from Marvin. If you have any of the kids that are on that list in your first period, they need to report to math testing. Thank you so much for your help.
All right, let's take out some problems from worksheet 4. So you guys picked up worksheet 4, which if you're joining online, I included that link in the chat box. It's also I also sent that link out in the remind from yesterday. Right, the C will turn into a number because we're using this to help solve for that number. Right. Yeah, so when you do a specific solution, all your C and K will eventually get replaced with numbers. So let's do number 2 from that worksheet there. So power rule that split up into individual fractions. So I'm taking the time to rewrite radical as rational exponents, and I'm also splitting them up into individual fractions. That's my first step because we just want to establish, oh, these are 3 smaller independent problems rather than one connected messy problem. And once we're inside each fraction, we can clean them up individually, pull the coefficients out, subtract the exponents. And then all through this stage here, we still haven't so I brought them up, but I could have just like left them here and just subtracted it. So 1 minus 1/2 is 1/2. 1/3 minus 1/2, the same thing as 2/6 minus 3/6, which is negative 1/6. And then 5 minus 1/2 is the same thing as 10/2 minus 1/2, which is 9/2. So you don't have to do that middle step that I have. You can just jump directly from here to here. So once we're here, every term is ready for power rule, and we can apply power rule with the next step. Okay. 5/4 stays, x to 1/2 becomes x to 3/2 over 3/2. Negative 1/6 becomes 5/6 over 5/6. 9/2 becomes 11/2 over 11/2. We flip all these fractions up as reciprocals. So 5/4 times 2/3, 1/2 times 6/5, 1/4 times 2/11, and then we just clean up. Okay, questions? All right, let's try number 3. So number 3 is seeing if you can recall your trig integrals. Try that. Secant tangent becomes secant. Cosine becomes sine. The negative still stays. Cosecant squared is negative cotangent. Sine becomes negative cosine. Okay, let me know if you have any individual questions. So we build our width formula first, 1 minus negative 1 over n. That's 2 over n. Put that 2 over n in for the width portions of your formula. And then your a gets replaced with negative 1. So there's my width, and there's my height. From here, we're taking this -1 plus 2 over ni, inserting it into the x, and then we're replacing this in for this functional. So 3 minus 2x squared. And then we're off to expanding, foiling, doing all the algebra steps there. Okay, distribute the -2 through after you completed foiling out your parentheses. Once your bracket is cleaned up, distribute your 2 over n through. Start using your summation rules to separate your summation 1, summation I, and summation I squared. Okay, pull all your highest degree leading coefficients out. So 2 over 1, 16 over 2, and 32 over 3. Any questions?